only way to create a legitimate sample from a population that we cannot get to. We cannot get to 300 million people unless we create a census. But we don't have the time and the money to do that all the time. That's why it's done every 10 years. So this is not the only scheme, if you want, procedure of sampling that is legitimate. So there are others, and I will mention them after we discuss this. So first of all, what is the simple random sampling? So number one, it uses randomization. So I want to stop here for a second and talk about randomization. Let's say we have 10 students. And I want to invite three groups of 2 to a dinner party. Okay, now I would like to randomly select several groups. I can use the first 3 groups or the first 5, choose or just get the first 3 groups. Select. Why did I write select twice? Okay, randomly select. I wanted to write several. Yeah, okay, several groups of 2 from these 10 students. So I would like to share my screen, and I would like to get to this. And first of all, nothing is really random. We will see when we look at a few examples in a minute. But let's say, give me a number, any number you want. Any number.
5.
Okay, so let's say we want to use 5 as our seed for randomness. Of course, once I put in a seed for randomness, obviously it's not random. Go to Math, select Probabilities right here. Scroll to the right, 1, 2, 3, and choose Random. It's already highlighted, and press Enter. So Store, go to Math, Probabilities, Random, and press Enter. So now I made the calculator use a so-called seed, which is right now it's no longer random, right? I selected something. And I would like to go back now, Math, back to Probabilities, and I want to choose number 8. I'm afraid that TI-83 does not have this option. I want to choose 8 random integers with no repeat. So I'll go to 8 directly. It will select 8 random integers with no repeats. Lower number is 1. I labeled each student. So I chose 10 students, and I gave each and every one a number, from number 1 to number 10. I want the sample size to be selected as groups of 2. And I press Enter. So now I would say the first group of students that I selected is the student with the number 8 and the student with number 3. I press again. It gives me another selection, and the second time I will choose number 2 and number 4. And I can continue. And now there is a repeat between the groups. I can just choose number 5 with somebody else, or I can continue. Just select the third group that has no repeats, because I already selected 4. I don't want to select 4 again. I can't. So this is the procedure of creating random numbers. I can have the same situation in which, let's say, I want to select one member of a Senate. So let's say we have 100 people, and I want to select comma, I want to select in groups of 6. Close the parenthesis with no repeat. It will give us samples of size 6 with no repeats inside the sample. And I can create as many samples as I want, but there will be no repeat. So in other words, if I label students or people between number 1 and number 100, I can select and say, hey, the first sample that I need consists of a person with number 59, 73, etc., etc. And you can continue. And I ask you now, I already answered this question myself, is this entirely random? No. No, it uses an algorithm, and of course it uses now the seed that we entered. You don't have to enter the same seed. You may not even get the same numbers, even if we both use the same seed, all of us. You may not get the same numbers. Maybe, maybe not. So, but there is an algorithm. So there is nothing completely random. But what is the idea here? So first of all, the simple random sample uses randomization. I'm not standing by the entrance to a store and ask people to answer questions. That's not random. In a way, it's random, but it's not representative of the population I'm trying to test. Number 2, all samples of size n, like I did here with size 2, or then in another example with size 6, all samples of the same size have the same chances of being selected. And this is called a simple random sample. This is the simple random sampling, and this is the simple random sample. It's done using randomization, and all samples of the same size have the same chances of being selected. So how did we do this? We labeled the students from 1 to 10, and let's say I wanted 3 groups of size 2. Any group of size 2 had the same chances of being selected out of those 10. And we looked at how we create no repeats with the calculator. Okay, so we are ready with this to start our homework. And I would like to talk about 1.4, which is not required, but I just want to just name other schemes, because I don't want you to think that if it's not a simple random sample, it's not accepted as a sample. So there is something, so other sampling techniques which are absolutely acceptable. I will not test you on this. I just want a number, just to give you an idea what they are. One is called stratified. Stratified, for example, let's say we all fit into one of the 3 categories. Let's say small size, medium, and large. Let's say everyone in the population fits these 3 categories. These are what we call a strata. Okay, these 3. Each is a stratum, right? So we're separating in homogeneous groups. A person who is here cannot be here, right? So homogeneous groups. So that's one way in which we can create an acceptable sample size from each category. An acceptable sample to study. Another one is called systematic. How do I do this? How do I create a systematic? Let's say the 5th person in a population. So I label everyone, and I call the fifth person. I call, let's say we have a population from 1 to 300, it's 360 million. And I invite into the study the fifth person. I label everyone, everyone has a number, and I call the fifth person, the fifth, the 10th, the 15th, the 20th into the study. That's a systematic. Also something called cluster. So in a cluster will be, for example, let's say we have 10 classes, math 135, and I randomly choose 2 of them, choose 2, and select or have in the study everyone in those 2 classes and all individuals in those 2 are selected. Okay, so that's pretty much. The next step will be bias and sampling, but I'd like to start our homework on 1.3. I'm going to share my screen. And where is my... Okay, sorry. Yes?
What's the most common form of sampling?
I would say that the simple random sampling is one of the most common. Very good question. Thank you very much. And what I wanted to say, very good question, Gabe. It also depends on the study. So, for example, the stratified sample is extremely important because if you want to study the effect of a medicine on a population, you want to stratify maybe based on age. You may want to stratify based on sex, because women and men have different characteristics, different functions, and so on and so forth. So that would be a stratified. Within the stratified, you will use a simple random sample for sure, and also in a cluster, for example, right? So you're gonna, in order to select 2 classes out of 10, you will use a simple random sample. You will use randomization before you select the class, and then after you select the class, then in the cluster you will perform the study on everyone. But I would say that the simple random sample is probably the most popular technique.
Thank you.
Thank you. Okay, I'm going to share my screen. Let's go to 1.3. Not the interactive assignment. That would be your responsibility. So let's look at the homework. So let's click on preview. And let's select what we would like to do. Few things before we move on.